Hey, it's Miss Delcom, guys. I'm just going to be going over Objective 1, 6.7. And question number 1, Frank spent $65. He spent $2 per day for 7 days. Then he was given $9 to divide equally between himself and his brothers. The following expression can be used to find the amount of money that Frank had after that. Based on the expression, what is the amount of money Frank had remaining? Okay, so key thing, we have different operations going on here. So the one thing we need to remember to do is order of operations. Order of operations, that's key to do first. Key thing in doing these kinds of questions. So we need to remember to parentheses, exponents, multiply and divide, which comes first from left to right, add and subtract, what comes first from left to right. So what I'm going to do here is just rewrite this question. So I have room 65 minus 2 times 7 plus 9 divided by 3. So we have no parentheses. We have nothing going on with exponents. We need to multiply or divide from left to right. So if I'm looking and I'm going through, I see this multiplication right here. So I need to do that first. So 2 times 7 gives me 14. So I need to bring everything else down. So 65 minus 14 plus 9 divided by 3. Okay, I need to go back. So I already did multiplying. Do I see anything else? Okay, I see this division right here. So I need to do that next. So 9 divided by 3, well, that gives me 3. So I'm going to do this and then bring everything else down. So 65 minus 14 plus 3. Okay, then I need to add or subtract from left to right. So if I'm looking here, I have 65 minus 14. That comes first. So I need to go ahead and do that. So 65, I'm just going to come over here to my math, minus 14. 5 minus 4 is 1. 6 minus 1 is 5. So I have 51 plus 3. My last step is this addition steps, which gives me 54. So my answer should be 54. I'm going to look and see if that's one of my answer choices. And it is. So my answer choice there would be B. Guys, on these types of questions, you have to follow the order of operations in order for you to get the correct answer. Okay. Next example is number 9. You have several questions like number 9 on this packet. So that's why I'm only doing like 1 or 2 of them. I'm not doing all of them. I'm only doing 1 or 2 to give you an example to kind of um, get your memory going about these questions. Okay. So number 9 says, which two expressions are equivalent? All right. One key thing that you can do here to understand this is give a variable a number. So let's say y is equal to 2. So wherever you see y, put down 2. So there's no harm in doing that. I like 2 because it's an easy number. Multiples of 2, dividing by 2. Oops. Adding by 2, subtracting by 2. It's very easy. So let's look at A right here. So order of operations still in effect. So I want to put a little note right there. Still have to follow the order of operations. So parentheses, 3 times 2 is 6. 6 plus 4 is 10. Okay. 4 plus 3 is 7. 7 times 2 is 14. Is 10 and 14 equal? Don't think so. So that could not be one of my examples. Could not be one of my answers. Okay, let's go to our next one. We need to do what's in parentheses here. So 18 divided by 2 gives me 9. 9 plus 10 gives me 19. 2 divided by 18. Well, 2 divided by 18 is a fraction. It's 2 over 18, which can be reduced to 1/9. So that would be 10 plus 1/9, should be 10 and 1/9. Give me 1 second. Sorry, let me zoom this in. So is 10 and 1/9 and 19 the same? No. Okay, let's look at our next one. Okay, in the parentheses, 2 times 2 is 4. 12 minus 4, that gives me 8. Is that equal to what's in parentheses here? 2 times 2 is 4. 12 minus 4 gives me 8. Is 8 equal to 8? Well, yes, it is. So this possibly could be my answer. Let's just check the last one to double check. 10 minus 6, well, that gives me 4. 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. 10 minus 3 gives me 7. Is 2 and 7 the same? No, it's not. So looking at this, C would be my correct answer. So a key note when you're doing these style of questions, guys, is to insert a number for the variable. Just like I did with y equals 2. I just gave it a number. You can give it, don't give it 1 and don't give it 0. Okay, choose an easy number. Okay, do not give it 1, do not give it 0, because that will change. That has some problems because you can add by 0 and nothing changes. You can multiply by 0, then something changes. You can add by 1, it changes. You could multiply by 1 and it doesn't change. So don't do 0 or 1. It has to be 2 or more. Okay, number 46, this is prime factorization. All right, so you remember your prime numbers should have this in your journal. We have this poster in our classroom. 1 is not prime. Remember, our first ones are 2, 3, 5, 7, 11, 13. Those are like the first 7. Okay, but 2, 3, 5 are kind of your big prime numbers. All right, so what is a prime factorization of 110? So remember, there's 2 ways you can do this. I'm going to do it 2 ways. I'm going to do it the way I like to do it because it's nice and neat and clean. So it's the upside down wedding cake method. So what prime number can go into 110? Well, I'm just going to know that ends in a 0. So bam, a 5 can. 5 can go into 11 2 times. Okay, which gives me 1. 5 can go into 10 2 times, which would give me 22. Okay, I can take out a 2 here, divide 22 and 2, which gives me 11, and 11's prime. So if I look at my prime numbers, here you have 5, 2, and 11. Those are all prime, and there's only one answer that shows that. Okay. The other way that you can do this is a factor tree. You can have 110, and we could factor it out and say, well, we could take out a 2, then that would be a 55, and then 55 is not prime. I could take out a 5 and an 11. 11 is prime and 5 is prime. And do you see we get the same prime numbers? Get the same prime numbers. Another trick that you can do, especially with these questions where it says prime factorization, you're looking for all numbers that are prime. And if you look at letter H, there's no way 22 is prime. So automatically you knew that one could not be my answer choice. Okay. All right, that was number 46. I'm going to go to question number 21 just because it's the same as prime factorization, and then I will come back to question number 12. All right, so question number 21. Question number 21, Mr. Gonzalez, show the numbers the students' parts of the prime factorization of 90, one factor is missing. Okay, so we've got to figure out what is a prime factors of 90. So again, this is a fill in the blank, so you can't use your strategies of eliminating, but let's look. So we have 90. Do my cake method. So I knew, well, it took out a 2. So let's take out a 2 first. And then half of 90 is 45. Okay. And then it took out a 3 squared. Well, that's 9. Okay. So I can take out a 3, which gives me 15. That could give me another 3. So that's where my 3 squared is coming in. And 3 can go into 15 how many times? 5 times. So 5 is my missing number. You can also do this as a factor tree as 90. And if your parents are helping you and they remember factor tree, guys, it's the same thing. We're still getting to the same thing at the end. So we have 2. You take out a 45. 45 can be broken down into 9 and 5. Okay, 9 is not prime. So we've got to break that down into 3 and 3. That's where your 2 3s come in, and your 5 is prime. So you have 1, 2, 2 3s, and then your missing numbers of 5. 1, 2, 2 3s down here, and your missing number is a 5. So 2 different ways that you can work out the same problem and get the same answer. All right, the last one that we're going to do, if you've already done this question and got it wrong on your on your Google Forms, there was a mistake when doing it, but do not worry because it has been fixed. Okay, so which expression is equivalent to 16 plus 2 times 36? Okay, so we have a lot of 2 squares, 2 cubes, 2 to the 4th power, and so forth. Okay, there's several different ways you can do this, guys. I would, just so I don't have to remember all the time, figure out what 2 to the 4th is. So I'm going to just come over here and do 2 to the 4th. Okay, I need to know what 2 to the 3rd, 2 to the 2nd is. All right. Oh, let's go ahead and do 3 squared and 3 cubed just to be on the safe side because those are the ones that were mentioned over there. Okay, so I don't have to remember going back and forth. Okay, 2 squareds, 2 times 2 is 4. Okay, 3 squareds, 3 times 3, which is 9. So knock those out of the park real quick because those are perfect squares. 2 cubed, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay, so we have 8 and then 8 times 2. So 2 to the 4th is 16. 3 squared is 9. So 3 times 3 is 9. 9 times 3 gives me 27. So now what I'm going to do is I'm going to take this information and transfer it over here and write it out. All right. So letter F is 2 to the 4th, so that's 16 plus 2 to the 3rd is 8 times 9. 2 to the 3rd is 8 plus 8 times 9. 2 to the 4th is 16 plus 4 times 3 squared is 9. 2 cubed is 8 plus 2 squared is 4 times 3 to the 3rd is 27. Okay, now we need to know which one is equivalent to the one above. Well, I know it starts with 16. Okay, so then I could eliminate some automatically then. But if I looked here and said, what's 2 times 36? Well, if I double 36, I get 72. So it's 16 plus 72. Well, if I look, which one of these gave me 72? 8 times 9 or 4 times 9? If you looked at this one, this gives me 16 plus 72. This gives me 8 plus 72. This gives me 16 plus 36. And this gives me 8 plus 108. So there's only one that looks like the top, which is letter F. Okay, I hope that helps you. Basically, there's several of these questions that repeat like this or repeat that shows equivalent expressions. All right, if you have any questions, just let me know.